Let us see one more question in your 2015 paper. So let us read. Arrange the following in increasing order of boiling point in particular sequence. This is the same question, almost similar question was given in 2016-17 as I've discussed earlier. Whenever boiling point question is given to you, it's almost the similar thing. They've almost given the same examples. So whenever boiling point is given to you, you have to discuss based on their either ionic interactions or speak in terms of hydrogen bonding or speak in terms of your dipole or speak in terms of your dispersion forces. But here, as you've seen already, I told you which is the organic compound which has least boiling point, your hydrocarbons. The maximum would be for acids. So when such thing is given to you, write the order. First would be hydrocarbon, which I already discussed in the previous video. First would be hydrocarbon. After that would be your ether. After ether, the next compound which is going to have a boiling point a bit higher than that is aldehyde. After aldehyde, next would be your alcohol, next would be your acid. So they have just asked us to write the order. So first thing, as the name suggests, you have to write the order. The least would be your aldehyde. So CH3, CHO. Please watch that video. It is almost a similar question. Only thing is they have just made it as C2H5OH. So aldehyde will have lesser boiling point. Next comes your alcohol. Alcohol due to only a single hydrogen bonding. Last would be your acid. So please watch the previous video. It's the same question as 2016 question. It's the same question. So just write the reason as I've given already for this. So acid would be maximum. Alkanes, alkynes would have minimum boiling point. Yes, that's your first question. Let us come back and discuss this question. Yes, so what is this question? They've given me a compound. As I said, every question paper has something called distinguishing test. Compulsory, you should know the distinguishing test for almost everything. I'll be taking a video for all the distinguishing test ones. So they've given me two compounds and they've asked me to distinguish this. So let me write this compound here and then I'll explain. So what did they say? They've asked me to compare between this compound and they've asked me to compare with this compound. Yes. Okay. Yeah. So when I take this compound, basically this is in your 2015, it's aldehyde and ketone chapter. Because I've written the question, let me explain that question to you. Now, when I speak or when I have to compare both, observe, this is your aldehyde, correct? This is your ketonic group. Ketone. Yeah. So what is the difference between aldehyde and ketone? Yeah, this group. This is your ketone function group and this is your aldehyde function group. So basically when I have to compare between an aldehyde and a ketone, right? Or aldehyde and a methyl ketone, rather, right? Methyl ketone. The only test which differentiates both of them is iodoform test. Iodoform test. Let us see. Yes, iodoform tests are basically shown by methyl ketones only. Methyl ketone. A group should be like this, adjacent. So, methyl ketone. So, aldehydes don't have methyl ketones. So, they do not show iodoform test. Right. They do not show iodoform test. So now what is iodoform test? Basically, iodoform test is something where I already said it is only shown by methyl ketone. They should have this group to show that test. So for this, I'm going to take like generally a normal methyl ketone. Just observe. So now this is your methyl ketone. Now this methyl ketone, when you're adding a base like sodium hydroxide, and when you're adding iodine to this, it's going to form an yellow color product or yellow color precipitate called iodoform, right? It will form an yellow color product called iodoform, because of which now once this iodoform is formed in the reaction, I can clearly say that this particular compound or the functional group present in this is ketones, right? Because methyl ketones only show this reaction. Aldehydes will not show this reaction. So let us see the mechanism for this. So for iodoform reaction, when I see the mechanism, for iodoform, just observe carefully. Yeah, first thing, what did I say? I require a base and I require iodine also. So suppose if I'm taking this particular thing, you can either pick up this and this, both are same. Instead of this particular group, there is one more extra alkyl group present. So if I take this compound, how does that look? In the step 1, now I have here, I'm writing this CH3 here, H, and H, right? And you have your C double bond O, fine. And again you have your methyl group, H, and H, right? Now, first basic important thing, I said there is a base and iodine which you're going to add to the reaction of the test tube. So first, iodine and iodine, observe carefully, and your OH, and your OH of the base. Now, initially there is a cleavage of the bond here, yes, so this bond is going to shift towards this, correct? And this H is going to react with this, yes, fine. So, and now this water is going to come. Let us see what are we going to get. First important thing, I am going to just take out I have to get I minus, done. Then I have to get water also, done. Then after that, this HI also is going to come out. Yes, this part is over. Now what are we left with? We are left with your CH3, correct? C double bond O, this one. And what are we left with? You're left with, now observe, this is gone, this is also gone, there is only one H here. Yes, so instead of writing this here, let me write this here. This is like this. Around carbon, 4 bonds. Fine. Now to this particular compound, when I said there is still one I minus left out, yeah, this I minus is going to attack this. So it's like this, I minus is going to attack this compound. Yes, now one extra I minus is here. How does this compound look? Now this compound, all the hydrogens are going to be replaced with this iodine. Yes. From here, after the replacement of iodine, all the 3 iodines. Now observe carefully. What do we get? I said we are going to get a compound called CHI3. Yes, CHI3 is a compound. Now this is your intermediate. Fine. Now observe. This is going to shift here. Then your OH of your base is going to, yes. So now let us see what are we going to get. We are going to just leave this whole thing, the whole bond here, this bond, yeah, get CHI3. This is your iodoform reaction, your LOPPT. Yes, this LOPPT is formed because of this iodoform reaction. We are going to clearly say that methyl ketones only show iodoform reaction, and your aldehydes, because of absence of methyl group, they are not going to show iodoform reaction.